Okay, everyone, this is our last section of 2.1, and you will figure out over the course of this year that usually we always end a section with application problems, meaning we're going to do story problems. We have to apply this. We need to figure out what's going on. As the year progresses, of course, application problems tend to get harder because we know more information. So, number 6, a penny is thrown straight down from a height of 200 feet. At the same time, a paintbrush is dropped from a height of 100 feet. The polynomials represent the heights in feet of the objects after t seconds. Okay, so we're dropping them or we're throwing them, whatever's happening. And then after time t, so after 1 second, if you would substitute in 1, it would tell you how high it is. After 2 seconds, if you substitute in 2, it would tell you how high it is. Letter A, write a polynomial that represents the distance between the penny and the paintbrush after t seconds. Now, think about this. Let's assume I get rid of these nasty polynomials because they're confusing, and I say that the penny up here is at 500 feet. And then I say the paintbrush down here is at 100 feet. And then I asked you, okay, well, if the penny's at 500 feet and the paintbrush is at 100 feet, did I say that wrong? Okay, the penny is at 500 feet and the paintbrush is at 100 feet. What's the distance between them? And I'm hoping you're thinking, oh, 400 feet. The distance between 100 and 500 is 400. Well, the way you find that is you take 500 and you subtract 100, and that gets you, oh, okay, well, the distance is 400 feet between them. We're going to do the same thing, except now we're going to do it with these weird-looking polynomials. So instead of 500, I'm going to use negative 16t squared minus 40t plus 200. And I'm going to subtract negative 16t squared plus 100. Now, in this case, if you notice, I kind of wrote my answer with parentheses. Were the parentheses necessary? And the answer is yes, because it's a subtraction problem. Okay, so if I'm subtracting, remember, you have to distribute that negative. So if I distribute that negative, instead of a negative 16t squared, I'm actually going to have a positive 16t squared. And instead of a positive 100, I'm actually going to have a negative 100. So if you accidentally dropped those parentheses, your answer would be wrong. Make sure you use them. Okay, the first polynomial, I'm just going to drop it down, negative 16t squared minus 40t plus 200. And then I'm going to look at combining like terms. So first of all, I've got a negative 16t squared. I've got a 16t squared. 0. They cancel each other out. Negative 16 plus 16, gone. Then I've got a negative 40t. He doesn't go with anyone, so negative 40t. And then last but not least, I've got a 200 and a minus 100, which is going to give me a positive 100. Okay, so that is the polynomial that's going to represent the distance between the penny and the paintbrush after t seconds. And if we want to be absolutely correct, we're going to put that in parentheses and we're going to put feet on it because it's representing a distance in feet. Letter B, interpret the coefficients of the polynomial in part A. Okay, so interpret the coefficients. The coefficients are the numbers in front of the variables. They're also just the numbers. So negative 40 is actually my leading coefficient, and we need to know what that means. And then 100 is not the leading coefficient, but it is a coefficient, and we need to know what that means. Pause your video, take a minute, see if you have any idea what these things mean. Now, once you start your video back up, I'm going to start with the 100 because that, in my mind, is a little bit easier. Negative 40t plus 100. Do you remember that question about what's the like initial distance, or what's the distance between these things? And I gave you the example of a 500 and a 100, and we said that the distance between them is 400. Well, if we subtract our polynomials and we get that constant back there of 100, that 100 is the initial or the starting distance between the penny and paintbrush. Okay, now the question is, as the penny and the paintbrush fall, are they always going to be 100 feet apart? They start 100 feet apart. The person throwing the penny is 100 feet higher than the person with the paintbrush. Are they always going to be 100 feet apart? Or are they going to get closer? Or are they going to get farther away? Is the penny going to fall faster? Is the paintbrush going to fall faster? What is actually going on here? And the answer to that lies with that -40. And that -40 kind of lies with these two words. Do you see the word thrown? And do you see the word dropped? The penny is thrown. The paintbrush is just dropped. So I know in here that we're going to have a conversation about, well, a paintbrush is probably heavier, but what if it's a foam paintbrush? Then it would be lighter. A penny's lighter, so a paintbrush probably falls faster than a penny, but the penny is being thrown, meaning that penny has a velocity. And I'm thinking something that's being thrown versus something that's being dropped is going to start moving faster or at a faster rate than something that's just being dropped out of your hand. So that -40 actually represents the initial velocity of the penny. And if you notice in your equations over here, that penny has this equation versus the paintbrush has this equation. 200 is your starting height of the penny, 100 is your starting height of the paintbrush. Hence, they're 100 feet apart. -16t squared, that's gravity. Okay, and that's gravity in feet per second. So gravity is affecting both of these, hence they would have, gravity affects everybody kind of the same. So they have the -16. Then your penny has this initial velocity because he's being thrown versus your paintbrush doesn't have anything in there because he's just being dropped. If the paintbrush had an initial velocity, it would also have a second term in there of whatever that velocity is. But anyways, take another second, take a look at that. That problem is done. And then I'm going to move on to our last problem. Number 7, write a polynomial in standard form that represents the perimeter of the quadrilateral. Perimeter. Distance around outside. Quadrilateral, four-sided figure. And by the way, you are responsible for all of that terminology. Okay, that's review from last year. So if you forgot, write it down and memorize it. Now, if I want a polynomial in standard form that represents the perimeter of this thing, well, I need the distance around the outside. So we're going to add them up. So I'm going to start with my 3x minus 2. That's one side. I'm going to add on my 2x plus 1. That's another side. I'm going to add on my 5x minus 2. And then last but not least, because it's quadrilateral, 4 sides, I'm going to add on my 4th side. Now, when in doubt, use parentheses. Use parentheses. I put everything in parentheses. Now ask yourself the question, do I really need the parentheses? The answer is no, because it's all addition. Okay, you really don't have to worry about addition. It's subtraction that'll get you. So I'm going to drop the parentheses, 3x minus 2 plus 2x plus 1. I'm not changing anything here. I'm just dropping the parentheses. Okay, all the numbers and variables are the same. Then I'm going to combine like terms. I have a 3x, I have a 2x, I have a 5x, I have a 2x. So 3, 4, 5, 10, 11, 12, that's 12 x's. Then I'm going to go find my constants. I got a -2. I've got a 1. I've got a -2. So a -2 and a 1 is a -1, and then another -2 is a -3. So -3. That would be the expression for the perimeter. And it doesn't give me feet, it doesn't give me inches, it doesn't give me units. So remember in the last one, we kind of put it in parentheses and wrote feet behind it. This one, I'm okay if you write it like that because that's what we were given. If you wanted to, you could say 12x minus 3 units, but that wouldn't be necessary because they didn't give you units to start with, so we don't have to give units to end with.